Hello, this is Eugene Blanchard, and this is part 2 of building a rocket stove. Part 1, we built this rocket stove that's shown here. It had some problems with it. The number one problem is that it was too small. So, example right here, I think I used this as one and a quarter by 1 1/4 inch square tubing. This is the feed tube. It was just too small to actually feed twigs and stuff and that was the whole idea behind it. The other problem it had is that it had a very small burner, right? So my idea was I'd have a small chimney, and then I'd insulate all this with insulating cement that's used for fire bricks and stuff like that, and it just didn't work. So there wasn't enough big enough oven, and then I couldn't feed the twigs in. So this is version number 2 or part 2, and now we're using bigger components. So for example, this is the main chimney part. It's a 2.5 inch square tubing, so it's quite a step up. I have a 2.5 inch tubing for the feed. The feed's going here, and then we also have this is the air intake. Air intake. I've got a 7 1/4 inch rectangular tubing. It's 1 inch by 2 inch, and what I've done is I've drilled a bunch of holes in it, and it's going to slide in here. So here's a close-up of the air intake. So I drilled 9 3/8 inch holes on the top, another 3 on each side, and then what I'm going to do is when it's mounted in, it's going to be mounted like this. So this will be our firebox or our oven in here, and then we'll have our feed, and we'll have some room around there. So when I've welded it in, there's a room on the side for air to flow into the oven, and on this end and on this end here. So the idea is that there will be a lot of airflow coming in. This shows that it's now welded in place. I got some welds on here, and what I've done is I've had my little square piece of steel here on the bottom, so it's all sealed in. So air will have room to go on the sides and on the top of it here. And then I've welded in the feed tube here also. This is a comparison between the two. So this is the original one. It had a very small feed tube. Couldn't even get twigs in it. It was just way too small. So now with this size here, this actually looks like it's 2 inch instead of 2.5 inch tubing here. So now I can feed a larger pieces of wood in, and that seems to be working a lot better. This one I was using insulated, so I was using the same 2.5 inch tubing, but I had it insulated. But still, my air intake was this 1 1/4 inch, and the chimney was 1 1/4 inch. A top view, right? So now we can see how big the chimney is and how large the feed tube for the twigs and the wood. We can get a lot more stuff in here, and just a comparison in size. Again, on the bottom, here's the feed tube comparison. Air inlet, probably about the same area, and we'll see how that works out. So on the very first test, what I found, it was very hard to light this thing. So I was using one of these barbecue lighters and put it in here, and it took a long time to get it to light. And when it was actually lit, we had a flame going and a little bit of charcoal. As you can see, there's almost no smoke at all. Like, there's no smoke here, which is kind of nice. And that's part of the goal behind making these rocket stoves, is that you won't have any smoke. And that good flame going on here, and that. So after that, I said, okay, great. What I'm going to do is make it stable. So I took some angle iron. So now I've got a 3-point rest on it here, and this is quite stable, extremely stable. And then on the top, I put a couple angle iron here, so then I can put a pot or a plate on it. Also, I welded on a handle right here. Not a great thing, because what happens is this gets hot, the handle gets hot, you can't touch it without a pretty thick glove on, and that. Just a top view showing, we've got our welded on pieces here, and then we can put our pot on. Another view, can't get too many views of this. And this shiny spot here is just where I had ground off the finish, so I could get a nice good ground for my arc welder, and that's what you're seeing here, and probably here also. All right, so what I did is I did a test. I took a aluminum pie plate and put a weeder on and fired up the thing. I had a pretty good fire going here, and it got just hot enough that it could sort of put a little burn mark on the wiener here, but the wiener never got hot, didn't cook. There just wasn't enough flow. And here's what I was doing is I took a piece of wood, and then I took my pocket knife, which is over here, and I cut off shavings, and I found that if I dropped it in here I'd get a good flame, and then I could take pieces going here, and then we'd start to get a fire. This is when I was trying to boil some water, and it wouldn't boil the water. It got warm. It got warm after about 15 minutes of flame, and that. So obviously this thing isn't quite working right. So here's the rocket stove. I've got it finally lit. It takes forever to get lit here. You've got a good flame going there. As you can see, there's hardly any smoke, but not much happening here. So it got me wondering, like, why isn't this working? And so I go back to this picture here. This shows the flame that's going on in the stove when it was working, and it's a little bit of a flame, not too much, right? And if I compare it and I look at the side, the flame was only about this high, right? And when I look at other videos of successful rocket stoves, what happens is the flame is way up here, and it's long flame shooting out, and some even up the top here. So I think what's happening is I'm not getting enough air coming in here, right? So I don't get the draft that actually gets the flame up here, gets to burn everything, and get the heat that I want. Like supposedly you're supposed to get about 1500 degrees up here, and I'm not getting anywhere near that, obviously, because I can't cook anything on it here. So one of the things I'm going to do is I'm going to hook up a fan onto here and just blow air in and see what happens there. And I guess that'll be part 3. All right, thanks for watching.